Decades of empirical evidence confirm a highly reliable consensus. Human contact with natural environments elevates mood and improves emotional well-being. But when we evaluate the cognitive record, specifically attention restoration theory, or ART, which posits that nature recovers our capacity to concentrate, that consensus vanishes. The data regarding focus and executive function is highly fragmented. This scatterplot maps the 80 experiments analyzed in the 2025 Bell et al. Systematic review. It quantifies the fragmentation, revealing a massive 35% null result rate and stark data heterogeneity across the literature. A failure rate this high does not automatically invalidate attention restoration theory. It points instead to a systemic methodological failure in how the experiments testing the theory are designed and conducted. Environmental psychology is currently facing a replication crisis because researchers forgot how to accurately define and measure the field's most foundational variable. The mechanism driving this replication crisis is a phenomenon known as operational drift. To understand the drift, we have to define two distinct states. First is subjective mental fatigue. This is purely a motivational signal, the conscious feeling of being tired, strained, or bored by a task. On the right side of this split screen is objective cognitive fatigue. This is a measurable biological state, characterized by a functional constraint in the brain's prefrontal parietal executive networks. Modern attention restoration literature routinely conflates these two states. The experimental designs shifted away from actively inducing objective cognitive fatigue, choosing instead to assume it exists simply because participants report feeling bored. If researchers rely on subjective self-reporting rather than verifying actual functional deficits in the brain, any claims that a walk in nature restored cognitive capacity become scientifically unfalsifiable. The psychological concept of directed attention relies on a specific biological substrate, the prefrontal parietal networks that mediate human executive function. Sustaining directed attention has a neurometabolic reality. High-load cognitive work causes a measurable accumulation of glutamate in the lateral prefrontal cortex. This glutamate accumulation physically increases the neural cost of cognitive control. It creates a legitimate functional constraint on your ability to concentrate. Yet, highly influential studies within environmental psychology attempt to induce this exact fatigue using tasks lasting only 5 to 10 minutes. Brief, low-load tasks trigger motivational lapses. They make participants feel bored, but they do not cause metabolic prefrontal impairment. If an experiment fails to create a genuine metabolic deficit, there is biologically nothing for a natural environment to restore. We can trace this error back to specific archetype studies, like Bertoro 2005, which established flawed conventions that subsequent researchers blindly replicated. In the Bertoro protocol, participants completed a 5-minute vigilance task, viewed images of natural or urban scenes, and then took a cognitive retest. This timeline of the Bertoro paradigm illustrates the test structure. To measure attention, the study used D', a signal detection metric that separates pure cognitive sensitivity from a participant's response bias. Plotting the baseline scores reveals the study's fatal flaw. The protocol included no manipulation check to prove the 5-minute task impaired anyone's D' baseline before viewing the images. The nature group simply started out significantly lower than the urban group. During the post-test, the nature group's performance did not exceed normal baselines. They merely caught up to where the urban group already was. Without verifying an induced impairment, the restorative effect of nature recorded here is statistically indistinguishable from regression to the mean, or simple relief from 5 minutes of boredom. The Berman 2008 study serves as the root of much modern restoration literature, yet it operates on the exact same unverified assumptions. In Berman Experiment 1, a 35-minute directed forgetting task was directly followed by an environmental walk and then a cognitive retest. The missing prerequisite is glaring. Researchers never tested performance after the 35-minute induction task. They sent participants on the walk without verifying if cognitive fatigue actually occurred. Any post-walk improvements in this setup could result from practice-based familiarization with the test. Alternatively, walking in a chaotic city adds a harsh, active cognitive tax that a quiet nature walk easily avoids. Early theorists understood this trap perfectly. Stephen Kaplan made the prerequisites for attention restoration theory explicit in 1995. This chart from Kaplan's foundational framework maps out the specific logic. Task demand must visibly cause a resource decline for impaired performance to occur. By ignoring Kaplan's explicit prerequisite of verifying the resource decline, the field spent decades building a literature on deeply ambiguous data. Fixing the replication crisis requires redesigning experimental paradigms to make attention restoration theory falsifiable again. The primary operational rule is simple. Restoration is a recovery claim, and recovery demands a proven deficit. This flowchart outlines the first two requirements of a rigorous protocol: a validated high-load fatigue induction, followed immediately by an objective manipulation check verifying a measurable drop in performance. Third, environmental exposure must utilize a three-arm design. Standard nature versus urban designs inherently conflate the potential restorative benefit of a forest with the active cognitive penalty of navigating city traffic. A neutral control arm isolates the environment as the single variable. Finally, the retest must measure actual capacity loss using a sensitive metric, like D', to rule out mere shifts in a participant's response bias. Only this strict four-step sequence can definitively isolate true cognitive restoration from arousal enhancement, individual preference, or simple rest. Neurophysiological markers, specifically frontal midline theta, offer an emerging tool for building a direct index of cognitive function and fatigue. But interpreting this data introduces a fatal complication known as the theta paradox. Frontal midline theta oscillations indicate states of highly alert cognitive control, and they also indicate deep cognitive fatigue. Because of this paradox, neural markers are theoretically useless without behavioral anchoring. If performance hasn't demonstrably dropped on a test, brainwaves cannot prove cognitive recovery. These methodological debates dictate outcomes far beyond the pages of academic journals. Multi-million-dollar urban planning initiatives, clinical healthcare facility designs, and corporate workplace biophilic interventions all rely entirely on the assumption of nature's cognitive benefits. These real-world applications require an evidence base built on verifiable physiological recovery, not the unexamined assumptions of operational drift.